This video is an introduction to JMP, presently using JMP 16, although the new version will probably look quite similar to 16, and also how to prepare data for analysis. So we begin by opening the JMP program. And you first want to look at some data. If you go under File, if you go to New, you can create a new data table and enter data by hand. That used to be the way students got exposed to statistics, is by entering small data sets. Hopefully you will never in your life have to enter data by hand. It's so readily available in electronic form that I rarely have an opportunity or necessity of hand entering it. If you go to Open, it's important to recognize that there are a variety of different types of files that you can open. If it's already a JMP data set, as the one I will start with here is, then you just can open JMP files and find the appropriate JMP file. If you're downloading data from the web somewhere, more likely it's going to be a text file, an Excel file. It could be in a different statistical format like SPSS or SAS file. It's important to make sure you have the right data type for the file that you're opening. If you have a choice between Excel and text files, generally you should go for text files, because as data sets get bigger and bigger, it's not unusual to have more than 1 million rows, and Excel won't allow more than 1 million rows. So if you open a large file as an Excel file, it will only give you the first 1 million rows, and then the rest will disappear, whereas text files could be of any size. So like I said, I'm going to start with a JMP file here, and it is actually I believe it's called IMED movie data. So when you open the file, the format of what you're looking at on the screen is there are a bunch of menu items across the top. On the left-hand side, it tells you information about the columns of data you have. These are what I would refer to as variables in your data set. And it says there are 20 columns currently. One has been selected. If you want to unselect it, just click in this blank area up here. Now none have been selected. When you highlight something, as soon as you highlight it, it's been selected, and it'll now say one has been selected. If you select another one, more than one, 2 have been selected. Again, turn that off. At the bottom, it says how many rows there are. There are almost 86,000 rows of data here. One has been selected somewhere there. I don't know why, but I'll turn off that selection. So right now, none have been selected. Usually you will have a data dictionary that goes along with the data set so that you know what all these mean, but often you won't. So, and that poses some difficulties, because you really want to understand what your variables represent. How were they measured? Who measured them? Almost every data set is subject to errors and misleading labels, incomplete data. This was actually a fairly messy data set I found. It does not have a data dictionary, and I've done several hours worth of cleaning this data to get it to this form. And as you'll see, it's not completely cleaned yet. When you start doing analysis, additional cleaning is going to be required. At least 80% of the time in data analysis is spent cleaning the data. So that is a big task, and it's one of the reasons why I use this program, JMP, is it's extremely friendly for extensive cleaning of data. Everything I do could be done using any statistical program, open source programs like R and Python, commercial ones like SPSS, SAS, JMP, which is a SAS product. All of these programs can accomplish the same things. The real question is how hard it is to do those. And for my experience, jump is by far the easiest to do fairly sophisticated things with. So that's why I'm using it, because it is fairly quick to get used to in order to do fairly complex things. One important difference between the appearance here and what it looks like, which is a spreadsheet, is jump is not a spreadsheet. And so you will not be doing very many things that operate on individual cells in this data set. Whereas in a spreadsheet, you're always working on individual cells, and you often copying and pasting is one of the most common things to do. You very rarely will copy and paste within jump. Jump is organized by columns. Mathematically, it's by vectors and matrices. And so the actions you do will operate on entire columns for the most part, as opposed to on individual cells. So you first open the data set and it's got this data, but you shouldn't assume that the data is in the right form for doing anything with. One question to ask yourself at the beginning is, what do you want to do with the data? Any data set probably involves something you're interested in. This happens to be data on movies. These are about 86,000 movies. The data comes from IMBD, which is a well-used movie data site, movie site with data about the movies, extensive data about the movies. This is only a subset of what they provide. And in particular, I have some information here about costs and revenues of movies. So I'm going to be kind of interested in exploring profitability of movies. And this data set will allow us to do some of that. So with the idea in mind that I'm focused on looking at profitability, that helps guide how much we need to clean up our data, or which variables are important to clean up. A few things at the outset before you do anything else would be go under File to Preferences. All of the platforms and menu items in JMP can be individualized, customized for your use. So you can pick various platforms, and if it's things like analyze a distribution, there are a bunch of items here that you can customize so that when you do an analysis using that platform, it'll look exactly the way you want it to, at least for the first view. You can always, things that are not checked here can always be added in interactively as you do an analysis. So this is just sort of an initial setup. Two settings that I'd like you to do for the initial setup, though, is if you go under Windows Specific, down here it says Auto Hide Menus and Toolbars. The default, I believe, will probably say based on window size. I would change that to never. All this does is when you do an analysis, if your screen is not very big, it may hide a bunch of the menu items. And it's always confusing sort of look at it and say, well, where did they go? This way, they'll never disappear. Regardless of the size, those menu items will always be there. I think that's helpful. So I would change that to never. And the other thing I would do is, I believe, see, I think it's under tables. Yeah, and the tables, if it's not already checked, where it says header summary graphs, say show summary graphs below column names. And I would also include the show missing data there. What that does is it allows you, when you look at it, to see underneath each variable a little snapshot of what is contained in that column of data. And you can toggle that to show up or not show up. Let me click this, it's back there. So now you want to look at the variables and start thinking about what do they mean and what type of variable they are. So you'll notice on the left-hand side in front of each of these columns, there is a little icon showing what kind of variable it is. The two major types are these red bars, and when it's a red bar, it is what's known as nominal data, and that means that they are in categories, the data. If you look at the blue ones, that is continuous data. That's measured as a numerical scale. Occasionally, you'll have ordinal, and ordinal you could use as nominal. The advantage of ordinals, there are a few analyses that work best on ordinal data. Ordinal data is where the data is in categories, but there's a natural order to the categories. And an example would be you do a survey and you ask people to rate agreement with some statement from strongly disagree to agree. And they've made 4 or 5 options, and they're ordinal. They're in a natural order. And it helps the program to tell it what kind of data you're looking at. If it's ordinal data, it can do some additional analysis. Very important to have continuous or nominal correct, though. If you have a continuous variable, like number of votes, these are rating votes by people on IMBD. If you change that type, which is easy to do, to nominal, it lists that there are, let's see, 5 and then 14,928 more categories, because it thinks these are categories, and it will treat each of these numbers as a category when it's a number of votes, which sort of doesn't make sense. So that should be continuous. When you look at a categorical variable, it doesn't make any sense to try to turn these into numbers. The one here where there's actually a choice to be made is the year the movie was made. Right now, the year is put as nominal. We could change, and notice continuous is grayed out. If it is, you can still change the type. If you right-click at the top and go to column information, it says it is character data nominal, so categories. You can change this automatically from numeric to continuous, and the same numbers are there, but the graph looks a little different. It's actually showing you what's called a histogram of what the dates, they go from 1894 to 2020, and you can see most of the movies that are fairly recent. And you could analyze this with year being continuous, or you could make it nominal. And with time variables like year, it depends on the question you ask and what kind of analysis you're doing. There's no automatic guidance that it should be continuous or nominal. Either could work. So what have we got here? We've got some easily to understand ones. I'll come back to the first few here. We have the year the movie was made, how many minutes long the movie is. Come back to country here in a minute, and language, a lot of languages, different languages for movies, although English is most, and I think IMBD in general is more steered to Western movies, and in particular English-speaking movies. The average vote is the rating by people. The people that submitted votes on a movie, it's a rating from 1 to 10, 10 being a really high-rated movie, good, meaning good in viewers' minds. The Metacritic score is a score given by critics of the movie, and that could range from 1 to 100. These columns are columns that I used or produced. They didn't come in. The original data set had a budget and a US gross revenue and a world gross revenue, but they were in different currencies, which was a bit of a mess. So I had to download data for exchange rates by year for a bunch of different currencies. And then the different years, you have to take into account what the inflation rate has done to a dollar. Because if you look at, for instance, Gone for the Wind, 1939, I believe, it didn't earn that much money in 1939 dollars, but in today's dollars, it, I think, has the highest gross revenue of any movie that's in the data set. So you need to take into account inflation. I've done that by downloading consumer price index. And so once I take the dollar revenue and budget figures, turn them into dollars through the exchange rate, and then update them for inflation, I came up with these last columns: the real budget, adjusted real budget, which I'll say something about in a minute, the gross revenues, US and world, and I also created a profitability column. Any of these columns that are created with formulas, you will see on the left-hand side, there's a little plus sign for the formula. So for instance, if you look at the real budget in US dollars 2021, I took the budget divided by the exchange rate, multiplied it by an inflation factor to get them to real dollars. In 2021 dollars, this is what the budget of these movies look like. The adjustment I made was that there are a number of movies here I discovered with budgets under $100. And they had enormous profitability because they earned, even if you earn $1,000 in revenue, spend less than $100, that's a pretty good return on that cost. But I highly suspect those are not correct. In fact, there were a bunch of movies that had budgets of $1. I don't think you make a movie for $1. I think that somehow that number got entered, and it's either a fictitious number or it was done in a country where the $1 cost was a nominal cost because it was a government-produced movie or something. In any case, I don't think sheds any real light on the profitability of movies. It's not a real budget figure, so I turned those into missing data. That's what the period is. Otherwise, I made that, I kept the number around for what the real budget is. It also turned out some of the movies had US revenues, some had world gross revenues. The world gross revenues often include the US gross revenues, but not always in some cases. So there's some movies that didn't earn any money in the United States, but earned it somewhere else. And so that you'd have world gross revenues, but not US gross revenues. Sometimes you have US gross revenues, not world gross revenues. So in order to come up with in order to come up with my profitability measure, what I did for the profitability measure is the following. And here's another place you could look at the formula. I could click on the plus sign on the left or just go to the formula here. I took the world gross revenues divided by the adjusted budget. Ideally, to look at profitability, you'd want to know when was the cost incurred and when did the money come in, and it's usually spread out over time. Fortunately for movies, it's a fairly short period of time. Most movies are made within a 2-year period, and they earn most of their revenues fairly quickly after that. And in any case, I don't have timing data. So a commonly used way to measure profitability of movies is to say per dollar spent, how much revenue does it earn? A ratio of 1 means it just earns back the money it made, which probably means taking into account the time value of money, is probably not profitable, but almost profitable. A number greater than 1 means potentially it was some profits earned on it. If the number is less than 1, it didn't even earn what it cost to make. It was clearly an unprofitable movie. But for the real world gross revenues, I did make one additional adjustment here. Because some movies earn money in the US and some earned it in the world, some earned it in both, I just said take the maximum of those two figures, whichever one's larger, divided by the exchange rate and multiply it by the inflation factor. So my real world gross revenues covers whether movies made money in the US or worldwide or both, some combination of them, it doesn't matter. as I said, I did a fair amount of cleaning, so it took quite a bit of time in order to get the exchange rates in by year and make these adjustments. So all that's done, so that's taken care of. But for some of the additional cleaning, let's take, here's one variable of interest, the genre. What kind of movie is it? And you'll notice that some of these have quite a few categories. In fact, if I were to look at analyze the distribution of this, look at all these different categories, some of which there are very few movies. So we have quite a few in horror movies, 2,268 of them. But we have, I'm sure I can highlight it even, maybe go down here to where they're all listed. Well, we have one movie that was listed as action, family, and romance. So what genre should we use? We could try to use all of those categories. My inclination is to say, well, maybe the first one is the primary category, and then if it also fits the other categories that was added in. But I want to be a little careful here, because another possibility, without a data dictionary, there's no way I can tell. Another possibility is they just put them in alphabetical order. A, C, W, action, crime, western, action, drama. Well, these are looking like they're in alphabetical order. Action, fantasy, thriller, action, history, mystery. So a lot of these pretty much look like they are alphabetical order. Adventure, drama, sci-fi, adventure, family. Yeah, so there may be exceptions. I think I had seen a few when I looked through this originally, but for the most part, they seem to be in alphabetical order. So that's going to create a problem. It would be pretty easy to just pick off the first word here. But because they're in alphabetical order, the first word is no more important than the other categories, could be any of those categories. So if we want to analyze this, that's going to cause us some problems. You get the little snapshots up here for each of these variables. If you want a little more thorough view of this, there are a couple of options to look at. Under columns, you can go to column viewer, and you can pick as many columns as you want. I think I'll leave out the ones that I used to derive my variables I used to calculate profits. So I'll take the ones that are primarily of interest, and you can click show summary and you'll get a quick snapshot of each of these variables. For nominal variables, categories, it will tell you how many categories there are. So notice actually there are some movies have more than one movie by the same title, because there are 85,855 titles, but only 82,093 categories. So we do have some movie titles that are repeated. Year was a nominal variable, so it's just telling you one was missing and 112 categories. So there's 112 different years in this data set. For a continuous variable like duration, it shows you what the minimum, the maximum, the average length was, 100 minutes approximately, and a standard deviation of the minutes. So you can get a quick snapshot this way. You also get the sort of quick snapshot showing up right under the title bar, which is in many ways more convenient. This can be very useful. I caution you, some data sets get really big in terms of number of variables, so it's not unusual to have hundreds of variables. I don't know that pulling up hundreds of variables and looking at this is going to be helpful, so you might have to end up doing them in groups. But the column viewer allows you to get a quick snapshot of what all the columns in the data set look like. Another useful thing is to go to, under tables, to missing data pattern. And you can choose what columns, you can choose them all. I'll choose the same columns. And if you click OK, you get a new data table that actually reports all the patterns of missing columns. So we have 6,881 movies. And notice, here's another thing to notice about JMP. I highlighted them in this little data set. They've also been highlighted in the bigger data set. And it shows now selected under it. I've selected 6,881 rows. If I had any analysis open, like graphs, it would also highlight these in the graphs. So JMP works where it's sort of integrated, selecting things in any one window, selects them in all the associated windows. You can also select them in the graph, and they'll highlight in the data set. You'll notice, all right, so here are 3 movies that are missing the language and missing only 1 column. Number of columns missing 1. 3 are missing the language. 3 columns, three movies are missing 4 variables, and this particular set of 4 variables, so it shows all the patterns of which variables are missing. Missing data is also often very informative, so it pays to sort of look at missing data. It often, if you just analyze data, JMP, unlike Excel, when data is missing, it just ignores it. It won't give you errors. It will give you an analysis of whatever's not missing. And so if the missing data is not just random, but is missing for a reason, the analysis you get could be quite misleading. Sometimes you want to analyze the missing data or understand why it's missing, because that's an important thing to know. So paying attention to missing data is often important. I also like to know just how much of my data is not missing anything. Well, it's less than 10% of the movies are not missing anything. You'll see many of them are missing data on budgets. So here, all of these, I highlighted the bar 1 here. That's missing the real budget data. And how many? 63,000, almost 64,000 movies don't have budget data. It's very difficult to get consistent data on budgets and revenues of different movies. So it's one of the hardest things to get, and the IMB data is quite incomplete because there's no requirement that movies report their budgets. So very often you'll find the financial data of movies is quite incomplete. It would also be nice to know how many movies, are there any movies missing everything? It doesn't look like it. Number of missing columns, the high seems to be 5 missing, here's 6 missing columns. And there are 14 movies that are missing 6 columns. So nothing is missing everything, but we only have 6,881 movies have complete data. Here's by far the biggest category. 42,000 movies are missing 4 columns. And those 4 columns are the score from the critics and the 3 financial variables. So movies that have no financial data and no score from the critics. These are probably lesser movies, probably not released from major studios. They may not have even gotten into theaters. So, we missed a lot of these movies are just not movies that probably any of us have heard of. And that's quite a few. It's about 2/3 of the movies. Okay, so missing data pattern, something to look at. It is a data set, so you could analyze this data. I'll just click no, I'm not going to save that. So back to the original data here. Let's take a look at, so genres would be complicated. What about country? This is another one where if you go down, go down far enough, you'll start seeing, well, there's lots of combinations of countries. So again, now the question is, are they in alphabetical order? UK, USA, yeah. UK, Turkey, Cyprus, no, that's not alphabetical. Just see if we have something that doesn't start with the US or UK. Those are by far the most common countries here that movies were made in. Yeah, so they're not in alphabetical order, UK, Germany, USA, Spain. The other concern I'd have, especially since IMBD, as many places seem to be sort of US or English speaking focused, it's possible that they put UK and US first and then other countries after, but apparently that's not the case because here we have UK, Germany, then USA. So I'm going to make a guess here, and remember, it's only a guess because I don't have a data dictionary. I can't confirm this. If I really care enough, and this is not unusual for me to do, I would try to find who issued the data, and I'd send them an email, and I'd ask them a question like, well, is it fair to assume that the first country listed is the most commonly used country? I don't know if that's true or not, but the author of this data, the owner of it, might be able to shed some light on that. I'm going to venture that guess right now that the first country listed is the primary country where it was filmed. So let's see if we can simplify this column, because this column has over 4,900 different combinations. So let's see if we can simplify it by creating a new column. Go to column, new column. We'll call it just a country, or maybe we could actually choose primary country, even though I'm not positive it's primary or not. When you create a new column, first of all, make sure you have the right data type. This is not going to be a number, it's going to be character data, which is nominal. As soon as you change it to character, this changes to nominal. We're going to create it, click on column properties with a formula. This is the formula window in JMP, and it probably the feature of JMP that takes the longest to learn. And the reason is because it's got an incredible number of different functions they built into here. Just like every function in Excel, there are hundreds of functions in Excel, there are hundreds of functions here. And so since there's so many, there's no simple way to learn them all. You just have to recognize what am I trying to do and see if you can find a function that will do that for you. So what do I want to do? I want to pick out the first of that list of countries. Well, it turns out under the character functions, there is a function called word, returns the nth word of the string. I want to take the first word, and the way the calculator window works, wherever the blue highlighted box is, that's what it's going to do next. So if I were to click on something else, it will replace the one with something else. So I want to move the box over to this. I want to take the first word out of the country data. Click apply. Okay, okay. And now it has taken out the primary country. It's down to about 260 instead of 4,900. It does pay to look at this a little bit more, just to see Maybe I'll analyze the distribution so I can see a little more clearly what all these primary countries are. So you notice a lot of USA, and I believe that's that's 2 USAs there. That's interesting. Let's go down to the list of them and see why that is. This is part of the data cleaning. USA and then USA with a comma. Well, that's awkward. That's both USA. The reason that the difference is if only the USA was where it was filmed, it would appear USA without the comma. If there are other countries as USA with the comma. So we're going to have to do something in order to have the computer recognize those are both, where the primary country was USA. And I believe there are some others like this. Notice UK and UK with the comma. So this may not always be the simplest way to do it, but I do believe this will work. Just want to close this little window if I can. My Zoom window is getting in the way. One option we can do is if you go under the column menu, there are a bunch of things you can do to columns here. We saw it create a new column. We can reorder them, move them around. We can create a formula. And under utilities, there are some useful things here. Combining columns, if you have a numerical, a continuous variable, and you want to put it into groups, you can create a binning formula. But there's also an option here, recode. And if you highlight recode, then it lists all the different ones that are there. And so we can recode anything that has the comma. We can try to take the comma off. And this would take a while to go through, so I'm only going to do a few of these. I definitely want the UK done, and I want the USA recoded. Let's leave the rest. Because to simplify things, by far, most of the movies in this data set are primary country is either US or UK. So for now, I'm going to, it has recoded it and put it in as a column called primary country 2. I'm going to create a new column. And actually, let me do it a different way. We could do it with a formula, but you could actually click the bar for US, holding down Control, click the UK. Those are 37,000 movies almost. Almost half of the movies have the US or UK as a primary country. And while those are highlighted, notice it says selected. There is an option under the rows command where it says rows selection. Here's where you can select rows, select where using different criteria, but we've already selected the rows. I'm going to name that selection in the column. And the column name is going to be US, UK, US or UK. And the ones that are not selected, I'll just call other. And now I have a new column at the end here as other, little bigger bar, and US or UK as the other category. The other way to select rows under the rows command, and you'll be doing this a lot, is go to row selection, select where. So we could select where US, UK equals US or UK. And let's make it a little more complicated selection. Let's add condition. And where our recoded primary country is equal to US, is it US or USA, I believe. We'll find out here in a second. So I put in two conditions. Your choice is to either select where all of those conditions are met or any of them. I want them all to be met. So of the US, UK, this will highlight only the USA countries as the primary. That's 30,910. Let's name that selection in a column. We'll call this US. Selected ones, USA, and unselected is other. So depending on the questions you want to ask, you may end up creating all sorts of columns. In fact, most serious analysis you do of data, you should end up with as many created columns, things with these plus signs or recoding of data, as many created columns as the original columns you had. It's not unusual to take a data set that's this wide and end up with one that's this wide. That's where your value added comes in rethinking what's the most meaningful way to look at this data. Don't feel confined by what the original variables are. Changing them is often the value that you add to the analysis. So just to complete the initial tour, in the next video, I will do some preliminary analysis, but just to show you what the other menu items are. Files, the usual things about opening and closing files, or potentially opening a file from the web page or database queries. So if you have a database you're accessing and want to pull the data out of it, database query builder is extremely useful. If you can do SQL programming, it's a great skill to have, but in fact, I am able to do SQL queries just using Query Builder without really knowing any SQL. It'll show you the SQL query, but its jump makes it much easier to do that. Edit is this usual edit things, and usually search and replace is the most common thing to do. You will use tables a lot, mainly when you highlight certain rows and only want to analyze those, you will subset them, put them in their own data set to analyze. And the usual things about sorting. Stacking and splitting is a really useful thing to do, although you will find that there's a more convenient way to do most of that. Rows, by far, row selection is the most common thing to use. The other thing is sometimes you want to hide and or exclude rows from the analysis. So if you think the data is wrong for some reason, or it's not relevant to your question, you better than deleting the rows, because then you don't get them back, would be to just exclude them, and the computer will pretend they're not there, but they are there. So you can unexclude them later on, bring them back. We saw a number of column commands. Don't know that. I think we saw the main ones. This is design of experiments, not likely to be an early thing that you will use, but used a lot in industrial settings. It's a very powerful platform. Under Analyze, there are a number of platforms. The primary ones to be aware of is if you're looking at one variable and want to examine it in detail, like we looked at a few here, analyze the distribution. If you want to look at two things in relation to each other, which I'll do in the next video, we'll look at fit y by x. Third major platform would be fit model, when you want to look at more than two things in relation to each other, fit model. And along with that, there's all kinds of predictive modeling platforms. So all of the sort of machine learning, artificial intelligence techniques, these are all available through predictive modeling. There are some specialized modeling here. A particular note would be time series analysis. And there are more advanced analyses under many of these platforms, clustering data. If you're doing consumer research, there are some special platforms in there. So we will mostly use distribution, fit Y by X, fit model, and also tabulate. Tabulate is a drop and drag interface that can restructure your data. So if you want to put primary country, let's say here, and let's say you want to look at year, nominal variable up there. Now you can see for each country how many rows of data, how many movies were done in each of the years. These later times you start getting much bigger numbers, of course. And if you want to see something about the movie, so you wanted to know, for instance, what their average budget looks like, you could click on the adjusted real budget and hold down Control and click mean. And if you release Control and then drop this into here, it will calculate the average budget, inflation adjusted budget for each country and each year, whatever number of movies was in there. So tabulate can be really useful. And one particular feature of JMP that's very useful is anywhere you see a red arrow, it means that instead of going back to the menu, you can dive in deeper. And so if you click on this red arrow, one particular thing that's useful is you can make this into a data table. And it is now a new data table that you can do any kind of analysis on. It has 253 rows, one for each of the recoded countries, which is not completely cleaned up yet, of course, and a column for each of the years. Lots of missing data, but where it's not missing, the data is showing the average inflation adjusted budget for that country and that year. And this is its own data set now. So making it into a data set can be really useful. Under graph, there are all kinds of graphs, although most of them have been replaced by just using the graph builder, which you will use a lot. Graph builder is another drop and drag interface that allows you to create any of these other kinds of graphs. So it was one of the later additions to JMP, which started in 1987. And when they created the graph builder, it largely replaced all of these. So these are there. And in fact, there's a legacy category where there's a couple more. Pretty much all of these have been replaced by graph builder that contains all of those. So the one you need to be aware of is the graph builder. The tools are also shown on this. When you do an analysis, they appear on the toolbar. And these can be useful for zooming in things. You can lasso certain points. You'll see some use of that in the next video. There are all kinds of add-ins available. If you go to the JMP community forum, then online you can download all kinds of add-ins that do lots of nice things. Like can take images and turn them into data, and all kinds of analysis. So those are the main menu items that are here. That's a good introduction to the beginning with the software. And the next video, I'll start doing some exploratory analysis.